Can you see it? Yeah? Is everyone can see this? Spectrum.
Yes,
Right?
yes,
Okay, good, great. And hold on, I will start to record the session so it will benefit those who have problems to receive, right? How do you, okay, down here, record meeting, get a set, all right, here we go. Okay. Just to give you a brief sort of, let's say a relaxing way of, getting to know what GIS is, right? Because we're actually learning sort of the basic principle, basic functions, and some of the what we call capabilities of GIS, right? And and how we could apply GIS into real estate. Just take note that GIS can range from a very simple way of approaching data to the most what we call sophisticated or advanced version, okay, of the data. Okay, if you simply Google through GIS in real estate or GIS in other applications, you can see a lot of information about it. But most of them utilizing GIS on its full capabilities that we talk about. The software used such as MapInfo, ArcGIS, ARCGIS. ArcGIS is the sort of the thing. The most sort of usable software and is most prominent one, right? In analyzing what we call vector-based GIS. And we also have some, sort of a lighter version of it, MapInfo Professional. We can also utilize that. Then the one that we have in the faculty lab, the computer lab, is MapInfo, right? But this year, since we're doing this online, we can't sort of utilizing that software. Okay, let me open up the section on data analysis with 8. We're starting at with 8. Please don't forget to sign your attendance here from the spectrum. And I've also put up sort of a short video of what a GIS is all about. And then throughout the lecture from now until end of the week, end of the semester, I hope you will be better understand what GIS is all about, right? And I also have put up, some reading materials if you wish to find out more about GIS and its application, and also a development on the GIS. All right, this one is a 16 sort of paper, an article that tells you about the sort of the growth, okay, or the progress of GIS, okay, from then until now. And I also put some exercises for you to do later on. GIS quiz, just a simple quiz, and as well as activity, okay, on Google Mind Map, right? So from now on, we actually want to utilize the use of Google My Maps, right? Okay. Okay, thus far, any questions? Very good.
So far.
Okay, good. All right. Okay, let's start on with the PowerPoint slide. Let me show you another slide. Hang on. Where does it go? Yeah. Where's my PowerPoint? Entire screen. Yeah, I think I'm going to open up it. My screen and then click on this PowerPoint. Okay, can you see this? The PowerPoint, yeah? An overview of GIS in real estate. I hope everyone can see this, right? Okay, so much about GIS. Let us all move on to how we utilize GIS in real estate specifically, all right? So a bit of introduction here. Normally, when we say about real estate, we are talking about, what are the things associated with real estate. Okay, there are a lot of factors, a lot of sort of items, attributes that can make up a real estate, all right? Because you are now in your third year, right? So basically you have sort of accustomed to know, okay, what are the things of the real estate, all right? So we have, talk about, the price, the value, the cost of a real estate, and we also know that price, value, and cost is not similar. Okay, they are different things, right? And then we also have talked about time value of money during your, initial years, during the first year. We talk about, money now, okay, can be capitalized to get a future income, and as well as, money in the future can be what we call counted, okay, to bring the money to the present value time. And then we also have, things or factors such as location, accessibility, and proximity. These are very important factors in real estate. Everybody knows that. And when you do valuation specifically, you are also taking note that location is basically the most important factor in determining the value or the market value of a property. And then there are other aspects as well, like orientation, how the property or the front side of the property, or probably not only the front side, okay, probably not on the front, but on the sides, on the rear, okay, orientation, how well it faces, right, face out, okay, whether it's north or south direction, east and view direction, because sometimes, it related to how well, the sun, okay, rise and sets. That brings in, not only the light, but also the heat, okay, from the sun. So some people are very particular about where does the frontage of the house most likely facing, right? They would avoid what we call normally and evening sun, right? And view, okay? View also is an important factor that could determine or that could contribute to a higher value of a property, okay, especially when you are at a further, high up in the sky, such as, apartments, condominiums, and all high-rise buildings. Okay, there are other factors as well. The physical characteristic is the main domain of the property. Okay, because through physical characteristic, we get to know more about its what we call functionalities. In terms of size, in terms of what best you can do with the space, okay, of the property. In terms of quality, layout, the design. These are some of the factors that are also influence a value, and then somewhat influence the potential buyers, okay, to get to the decision to buy a property. And then on a larger aspect, we are also note that neighborhood where the property is located, right, is also play an important role, okay, in deciding, let's say, where to buy a property, and then whether within the neighborhood there are what we call public and private amenities or facilities offering what we call services, all right, around the house, around the neighborhood of the house, and in the immediate what we call surrounding of the house as well, so that as a homeowner, basically you can get whatever you want within easily reach, right? Maybe your house near to a shopping mall, but it's not that near, okay. So you can utilize what we call your weekend to get some recreation, relaxing time, or to buy things, all right? Or maybe some owners prefer to have a house near schools, all right, or good schools, or near shops, restaurants, okay, and all other public amenities and facilities. And there are a lot of other factors if you will want to list them down, right? But there's actually one characteristic that differentiate one real estate from another, and obviously we know about it. All right, it is actually the location, okay, of property. All right, and in the basic in the back, right, of the principle of the property, principle of the valuation of property. Right, we always talk about location. that play an important role in deciding or determining the value of a property. And a lot of what we call decisions made, right, by owners, by buyers, by investors, they are all related to somewhat, location of the property. Because in location, we get to know what we call the prospective growth, right, of an area, and we also get to know the surrounding of that place, of that particular place. Because when we have a particular location, that location would somewhat associate with other places, right, nearby and the near surrounding, as well as the connection between that place to other location as well. Basically, location is very important in real estate. It is also important in geography, right, as well as important in GIS, because GIS means Geographic Information System. All right, we see about it. What does it mean? Sorry about that. So basically, what about location? Normally, when we want to inform about location or when we want to find out location, we would normally refer to a map. All right, be it a paper map, be it a map on your smartphone, a map from the computer, a map from tablet, or a map from anywhere. All right, and sometimes if you were to ask direction from a person, right, at that place, that person also could basically think about the location. Let's say you want to ask to go to a specific place, okay, from point A to point B. Okay, those person who already have been there would be able to describe it, okay, because describe it in words, all right? Not only describe how to get there, but the person might also inform you about the typical, what we call landmarks, or typical signs, all right, around the route, okay, from A to B, that you can identify or associate with, okay, when you want to get to the place. But nowadays, with modern technologies, right, we have the facilities or the ability of getting to one place from another by utilizing the mapping navigation software, right, like Google Map, like Waze, right, that it does not only get you from A to B, but it can get you from A to B the shortest time, and providing, or sometimes, not only the shortest time, but avoiding those sort of crowded or traffic areas, traffic roads, okay, traffic places. So location can inform us not only about the position, but it also leads to what we call other things as well, okay, associated from that particular location. So how do you identify and explain the location of real estate? Basically, there are two ways, but it's real position. All right, this one you can notify from the what we call property identification, or in real, it is actually the title document. Right, it title document the information that what number, Mookie, street, and sometimes the title document attached to get the site plan, but the relative position of that land of property from by getting a title document, right? And sometimes you also have what we call the directions, all right, Cartesian, or in what we call this in geography way, all right. You will see that A is actually north of B, for example, or A is located in the right. Like, for example, where does its position in? Okay, we are normally say that Malaysia is in the southeast of Asia, all right. So from that we can visualize, roughly where is the sort of location of Malaysia, all right. And we also, the more common ones, we could utilize, or we could test them to look at it. Okay, nowadays in urban areas we have building of houses, not numbering, but also proper road street, okay, names. Okay, we also, let's say Ain'ni, Jalan, let's say Jalan Ara, okay, and then you have postcode, and then you have the immediate what we call city. Let's say Namati, Bangsa, Kuala Lumpur, right? So that's how address looks like, okay, in Malaysia, okay. And sometimes we have the postcode 50603, okay, Bangsa, Kuala Lumpur, right? But the immediate city is actually Bangsa. But in other countries like the Kingdom, right, they use what called a street postcode, okay, not a postcode. That's actually different with Malaysia and UK. Okay, because UK put a very specific postcode on the address on the road level, right? You can better identify the property at street level, right? When you use a GIS, for example. Similar to they use what we call grid system, because a grid base shows the direction in this way, okay, north of or what, southeast of what, okay, intersection of what road, right? That's how because different countries have different way of telling things about location. Okay, for Malaysia, we add code, although an error code would cover a whole lot big area. Let's say you say 50603 or 5900 is passport code. Okay, so we can judge where is the location of a thing when we want to start this. Okay, if we were to find out a specific what we call is getting the code information, right? We can't do that. But basically to look at the address, or sometimes only the address, you can through a landmark, okay, a proper building. Let's say we're talking Maybank Tower, Maybank Bangsa, for example. So easily to identify, right? And the other way is actually by looking at the proximity, all right? A distance to, it could be a driving distance, it could be a physical distance, right? And how near a place to one another. And we can also set the proximity by way of traveling time. All right, because traveling time will take into account the traffic movement, traffic condition on the road. And then the other way of telling location, especially for geography and for GIS, is by looking its absolute position on Earth. All right, because tells us, nearly what we call real time. All right, on aspect location. Okay, by reference or by using or utilizing what we call geographic coordinates, all right, XY position. Okay, this is actually a way of what we call telling or informing us about a specific location on Earth, all right? So any position on Earth in what we call geography or GIS concepts, right, would simply have this coordinate XY position, okay, on it. So basically, if you were to utilize GIS for analysis, we need to find a map that has a proper what we call projection, right? Projection that informs us about the coordinate XY position. Projection means because the world is actually a spherical size, right? It is round, okay, it's spherical, right? So when they want to create maps or find a position on the map or on the world, all right, they need to project the circle or the spherical shape into what we call a 2D shape, a 2D paper map base, all right. So they are doing some sort of transformation from the globe onto what we call a 2D, what we call a 2D representation, okay, of the position. So that's what we call a transformation, right, of globe to a map, okay, XY coordinate, right. So each different country might use a different sets of projection, but there is actually one way of a universal way of informing about geographic coordinates by way of UTM. They call it Universal Transverse Marker, right? you can Google that, UTM. Okay, it's actually one sort of transformation, right, of a globe to a map, to an XY position, okay, of a location on a map. So this is actually what we are utilizing on spatial map in GIS, right? And of course, the other relative position could be the what we call attributes of this spatial map. Right? We can also couple or combine these two onto the GIS database systems. Okay, by getting to know the position, the actual XY position, and associate this XY position on the data about the lot number, about address, about proximity, about the relative position north of southeast of whatever, right? That is actually one way of sort of informing location in GIS. So basically, location is fixed, usually relates to the world reference system coordinate by way of latitude and longitude. All right, you might want to sort of bring back your memory, okay, on geography subject that you have learned previously. That would must be very helpful, okay, in understanding this thing. Okay, obviously latitude and longitude determines the correct position, right, of a specific location on Earth, right? And of course, longitude would be based on the what we call the north as well as the south sort of pole, okay, which is supposed to be the center of the globe. And latitude goes around horizontally, and it actually centered on the equator, right, where Malaysia is, supposedly located near to it, right, by certain sort of degrees, okay, degree angle, right. So basically, a grid system is established that will allow any place on Earth's surface to be located. All right. For example, location of point A is here, point A, and we can actually inform point A is actually 1 degree north, right here, 1 degree north latitude, and 3 degree here, 3 degree east longitude, right, based on this what we call latitude longitude, right? And let's say if I open this up, it will somewhat link to the to this website that you can simply find the what a location. Let's say you type a place, let's say Kuala Lumpur. You find, okay, and then it will simply give you the position, okay, the XY position, which is actually 3.1 degree north or south, whatever, right? And then 101.68 degrees of the longitude, right? So this is actually a way of telling where is basically Kuala Lumpur. Right. So from that, we could also find, other points, other locations, all right, on a specific place, all right, like point B, C, D, E, and F, all right. We could also tell through this grid system. And GIS can help to establish the position of a state in relation to other geographic features of a location, right? So from the information about the proximity, we can also note, let's say Lembah Pantai is located somewhat in the center, right? Okay, somewhat, okay, in the center of the federal territory boundaries, right? And we could also say Mukim Batu, okay, is located, let's say, north of Lembah Pantai. That is actually how we describe a location of a specific place or specific position. Right? It could be a point, a small area, a larger area, a district, or a region. Right? It can grow from a small place to a bigger area or bigger coverage. So basically, geographic information shows information about places on the Earth's surface, the knowledge about what is, where, and when, right? As well as relationship between one feature to another. Okay, the one that I informed you just now, right? How it all began, a bit of historical facts about GIS. It all began by the work of a land surveyor, all right? Because what land survey does, they basically collect raw data by observing and measuring, right? Position, right? On Earth, right? We can see sometimes when we drive around, highway or some roads, could see some people standing, by the roadsides, holding some sort of a tool, right? We call it a theodolite, okay, to get measurement, okay, of not only position but as well as elevation, okay, of the place of the area, right? That's what land survey do. And then land survey pass on this material, this data, okay, collected on field, okay, to a cartographers, right? Cartographers, they basically draw maps, right? Traditionally, okay, in probably in the 60s and 70s, but nowadays cartographers utilize what best known as a map, what we call the AutoCAD, right? AutoCAD, okay, AutoCAD drawings, software, right, to draw maps. Okay, they can also draw maps digitally, right, not by using what we call traditional way, okay, of cartographers, okay, of sketching a map, right? And then later on, when we want to transform the paper maps, all right, drawn by the cartographers, we want to make those maps digital. That is where what we call GIS came about, all right? When GIS came about, we simply have a map, similar maps of what cartographers have drawn, okay, into what we call digital forms, all right? Of course, development, okay, over time, we would want to utilize, technology, right, in order to enhance what we call the capabilities of the map, of the data on the map, all right? And there are, of course, a lot of advantages, okay, when we utilize GIS. It can easily update information on the map, right, by putting in any new information, and that information could also be sourced out, okay, from other resources, right? And we could also simply not only add new information, but we could also delete, or we could also throw away any information that are no longer relevant, and we can keep that, okay, as what we call a file database, all right? And for cartographers, or for a drawn map or on a paper map, we have to have what we call a larger rooms, okay, a larger storage area, okay, to keep all the paper-based maps, all right? And we have a lot of different types of maps, right? Not only location map, sometimes we have what we call a topology map, we have elevation map, we have what we call a site plan, floor plan, sometimes we have internal layout, a height plan, and so on and so forth. So there are a lot of maps to be kept, all right? So when we transform everything into digital form, it would make what we call the storage and retrieval, okay, on the future day more better, all right? We just need to invest in a bigger size of the what we call memory, all right? It could be hundreds of gigabytes, all right, just to keep on updating maps on a digital format. Okay, here I'm showing you a timeline, evolution of GIS as a discipline. I think GIS took about, as a major role, okay, in analyzing what we call real estate or geographic data during the, 80s, during the 80s, right? When we have what we call 80s, late 80s and early 90s, okay, when we have a proper what we call over internet, okay, set up, right? And of course, we have the first company who established the GIS, right? We call it S3, Environmental System Research Industry, okay, based in California, right? You can Google S3, you would find a lot more information about GIS as well as its sort of major software developed by S3 that is actually ArcGIS, ARC-GIS, right? Developed by S3 is actually the pioneer, okay, in what we call GIS mapping. And along the way, we have a lot of other developments in terms of new tools or new way of getting data, getting geographic data, right? By Earth satellite, by GPS navigation, and then like Landsat, AirDAS, Odyssey, EDC. These are all other companies that have also developed what we call their own proprietary software, okay, on analyzing what we call vector-based GIS and raster-based GIS. Okay, we actually going to look at that in our future lecture, right? And then I think beyond like 2000, the GIS have been, further evolved or further developed into what we call web-based or into app-based, okay, application-based, okay, of the technology. And now with the things associated with big data, i.e. industrial revolution or IR, so basically the use of GIS might be well suited, right, to go in tandem, right, with the developments in other what we call information technology, right? Okay, land survey. Okay, we know what is land survey. It's a discipline. More important is actually measure and collect data about physical Earth. All right, and then a land survey, somewhat near to us as well. Okay, because we get our land, what we call that land. We got our parcel plot, right? From the land survey, and if you were to determine the boundaries and the exact measurement, right, of let's say of a property, of a site, right, we have to rely on a land survey to provide for that, right? And then a lot of information important for property. So it's in the way will be constructed. It settled property line disputes and okay, right of ways is whatnot, right? And then it will lead to the creation of map. Alright, that is actually how important a land survey is. And then this is actually some sort of description of what does a land survey do. They measure not only distance, but they also measure the what we call bearings, alright, position, okay, from one place to another, as well as the elevation, okay, the height, okay, of a point on Earth, right? And cartographers, okay, they are the people who make maps. Okay, if you look at these two pictures, okay, these were the old days, okay, of the cartographers drawing maps, okay, as what the land surveyor has collected. Okay, this actually happened during the 60s and 70s. But nowadays, we utilize more of the software, right? By utilizing GPS as well as, AutoCAD, okay, software to draw a map. And GIS, okay, this one goes a little bit further because GIS usually associated with computers, right? Basically, it's a system of computer, software, hardware, data, and personnel to manipulate, analyze, and present or visualize information that is linked to spatial location, right? And then it is actually a computer system capable of assembling, storing, manipulating, analyzing, what best computer do, then GIS also can do that, right? So basically, we rely on the power on the technology of a hardware, right, or software as well, in order for us to develop a good what we call GIS database system. Right. So when we say about GIS, we normally associate with computers, and then in terms of data, we are actually looking at the digital map. So we have computers or digital maps into computers. All right. And then what can we do with that? Right. So basically, there are a host of other applications that we can use or utilize the functionality of a GIS that are stored in a computer. Some definitions of a GIS, okay, from history until later date, all right. Of course, in 1986, it is actually a powerful set of tools for collecting, storing, retrieving, transmitting, displaying such data. It's all about a database, or we call it a spatial database. A GIS project would normally start with a GIS database. Okay, you need to have a set of database in the form of digital maps and any other information or tabular information associated with the map. Okay, that is actually the two sort of common types of data in a GIS. And then Haxel also mentioned that GIS refers to computerized database system, and then it could basically utilize all of this function. And then S3, which is actually the pioneer of GIS software and hardware, right? Software and application. It says GIS integrates hardware, software, and data for do all of this processing function, right? Of what we call geographically referenced information. And then Liam Wong in 2001 says GIS is most useful when used to perform spatial data analysis. So basically, the main capability of GIS is basically to perform analysis on the spatial data. When we say spatial data, it is actually the map itself, right? So when GIS is becoming more prominent, is in the way how it performs what we call analysis, okay, of the map. So basically, in other words, GIS is actually a representation of the world in digital form. Okay, basically what we see out there is being what we call transformed onto a computer database system in the form of digital maps. Okay, what you see out there, bring to the computer, and then the computer store it as a digital form. All right, that is actually GIS. GIS allows you to visualize the data as a map. All right, the first one here, we have a map, right, and then we also have the attribute, okay, of the map. All right, let's say a location on the map. I said just now, we can simply look from the map position, and then the address, okay, the house number, basically the jalan, okay, the road names, or the bandar, town, and postcode could basically be stored as a what we call attribute database. So basically, GIS would combine map or spatial database and what we call attributes database, and then these two would become what we call a component in a GIS database. And then we can also utilize map in different ways, okay, by looking at the point locations, or we could also look it as a sort of grid base, and then on a larger base, and on what we call a modeling sort of base. I mean, there are many other ways we can visualize a GIS, right? That suits to whatever applications by the user. Okay. And this is actually the GIS component typical to any information technology. Okay, component. Of course, we need to have a data, the first one, right? And then data is actually a spatial data, and the attribute data. Remember this data, map data, as well as any information related to the map. Okay, that is basically the data for the GIS. And then we need to have what we call the hardware, computer, PCs, printers, right? Memory, basically, right, to keep the data or to keep the spatial data, all right? And sometimes we also need to have what we call plotters. Okay, that plotters actually can be used to draw maps digitally, right? You draw on the plotters, and then the plotters would simply some sort of transfer the drawing onto your screen, right? and as well as digitizers. Okay, that is actually another way of capturing, or what we call putting data into a GIS map. And then we have a proper software, GIS software, database software, and sometimes GIS software could also be what we call link, all right, to other types of database like Excel or maybe Statistic, all right, which of there is computer aspect to link between software, GIS and statistics software. For example, it's software, GIS, right? So you need to have what we call coupling, okay, in between, right, to link GIS and statistics. So you need to have a bit of what we call a program, right, to link those two. And then, of course, we need to have people to manage the project, right, manage the database. And we also have what we call sets of methods, okay, what best we can do with the spatial data, all right? It could be guidelines, procedures, it could be a function, right? But these methods would be based on, the type of software that we acquired and that we have, okay? Because certain software can do much more, and other software might be a lighter version, okay, of a GIS, all right? But for us, we would only utilize a Google My Map that has a little, somewhat capabilities of showing spatial data or spatial data component of a GIS, but not so much of what we call the analytic capabilities. All right, that is actually our disadvantages. Okay, doing the subject basically, online, right? We can't utilize the lab for this one, right? Okay, let's say data in GIS. Okay, we have talked about this. And I want to highlight here, basically in GIS, we have two data types, all right? One is spatial, that is basically a map, all right? That has been referenced, okay, to its location, okay, that XY location. And then we also have what we call non-spatial map, okay? Sometimes they call it attributes, and some other terms they call it a spatial, right? So spatial and a spatial, right? So a spatial or non-spatial, that they are data about the spatial map here, okay? Usually in form, in a spreadsheet form. Okay, sometimes you can find it from Excel or from Access, right? Any database, what we call functionalities, can be used to store what we call non-spatial data. But if we were to utilize GIS on a software, a GIS proper GIS software, right? That software already have these two what we call database capabilities to store spatial database, to store spatial data, and as well as to store what we call the attributes data. So they have what we call a built-in spreadsheet function there in the software when we utilize what we call a GIS software. Okay, show you an example of a map, risk data in GIS. All right, this is actually a map of a neighborhood area. This is actually in Bangi, all right, and we can see, from this, sort of brief map, right? We could see there are different sets of all the road networks, Jalan Surada maybe, or Jalan 8, orbit 28, Jalan 8, orbit 7C, 70, and so on, so forth. So we can see a variation of street networks there, all right? And among other things, we also see the what we call the parcel, right, or the lot, right, of the property, okay? And these actually can be a spatial data, a spatial map. We can simply draw around the boundaries and take that as what we call a spatial or a GIS map, all right? And we could also see from this map all these dotted signs, all right? In red here, in blue, and in yellow, all right? So these also can depict as a point position, all right, of that location, okay, and can be put onto what we call a digital map, all right? For example, we take this Tariqa Crystal Creative, alright? This shows us basically there is actually a Tariqa Crystal Creative, alright, on this location.
Senang je.
And in terms of visualization, alright, of a map, okay, when we simply zoom out a particular location, sometimes the maps would only inform us about a point location. Okay, let me open up Google Map. Yeah. Oh, sorry. Do you see my Google Map?
Yes.
No. Google Map, yeah.
Yes. Yes.
Okay. If I zoom in and zoom up, you'll be able to see, right?
Yes.
Okay. Great. So basically, let's say Bandar Parbangi, right? If you zoom it out, okay, on a larger aspect, right? So we could also only see Bandar Parbangi as a dot, okay, as a dot position, all right? So basically, if we were to zoom in, okay, Bandar Parbangi, so Bandar Parbangi has sort of other components, not only a point position, but all of the other what we call neighborhood sections, right? Section 1, 2, 3, 8, 7, 9, and so on and so forth, and all other establishments. If you were to zoom in to more what we call smaller, more larger, okay, visual. So we could see each of the boundaries of the properties in that neighborhood. So basically, it depends on how we visualize things, okay, on a map, right? If we were simply to zoom in, we could see a proper what we call boundaries, right, of the map. Okay, let's say we can also put it as a satellite view, so we can see the actual look, right, of the property there, right? But somewhat, if we were to zoom up, okay, zoom up, okay, we can only see like a variation, a layout, right, of the entire place. That's actually how simply we visualize what we call GIS, provided that those data are available in the GIS sort of database. So basically, any geographical objects or any position, okay, you could simply adopt that as a GIS data, all right, into the GIS systems. So how do you identify special data? All right, it's quite simple. Where is object P? Okay, object P is located somewhere at 12 north and here 3 east, right? Based on direction, right? Normally when we point up, it's usually north, all right? But that's not so, right? That's not entirely true from the way we look at what we call a lot plan, right? A parcel plan or a site plan, right? Because site plan has this arrow direction, right? Sign. Okay, it could be north like that, or it could be north like that, right? But it could be this way, it could be that way, and so on and so forth. So depending on the actual what we call measurement, right? Be it by the surveyors, right? But for easy understanding, we just take north as the most up, okay, in this case. So basically, we could also tell what is the location of S, okay, by looking at the grid position. If we don't have any address or any particular location to explain about a location, so we could see explain location is right. So location of S is basically north, or it could be for west, all right? It could be a center, right? Between north and south, right? Depending on how we describe it. What can be found at 11 south and 5 east? This is actually okay, 5 east and 11 south, right? Based on this information given, right? And what object is nearest to R? Of course, by looking at the map, we note that it is actually Q, right? And we could also, ask or query other things, okay, associated with the map, right? We could also tell us about, the dimensions, the size, the shape, all right, of the object, all right, and like S actually has some lines, okay, running across it, okay, and we also have, other sets of sort of notable descriptions of the properties, okay, of the map. And what about attribute data? Okay, from attribute data, like I said just now, it is actually a simple spreadsheet, right, in the form of rows and columns, right? And we also could analyze attribute data that are associated to a map, all right? In GIS, this map, a special map, they are linked to these attributes data or attribute information. So from this database, special and also non-special database, or special and attribute database, we could also ask questions, right? Let's say what is the attribute of number 3, okay, and how is it different with number 4, right? So from the data, we can point out from the query function or from the search function, okay, in the system, we could ask that, okay, it does only show us the data in terms of attributes, but it could also display together with this spreadsheet map data. It's showing us all of this information as well, right? And then we could also further ask who live at Jalan Ubi, and then the system would simply pop up, right? Answers or dialog box, okay, in the form of answers. It tells us who are basically living along Jalan Ubi or own a house at Jalan Ubi. And then how many properties have more than 1,800 square feet of footage, and where they are located. Okay, basically there are 4, right, properties that have a footage of more than 1,800, all right, and then they are located at Jalan Ubi as well as Jalan Aka. It is actually just some theoretical way, okay, of explaining what a GIS function, right, can be done, right? Probably in the next lecture, I will show you some of the actual software used, if I possibly could get one, all right? Because in order for me to utilize GIS software, I also need to have a licensed one, which usually we have it in the faculty, right? But I will try to dig up some way of getting the software. Not illegally, obviously not, okay, but some other ways, right? Maybe I could use a trial version, right, of the software, okay, and then we try to navigate through some other functionalities of this one, right, of this query function. Attribute data query, okay, we could also further query in logical ways, right? Yeah. Or in what we call hierarchy way, right? Selection of an item according to rules, for example, which sort of area, which property, okay, land has these features, right? Area of above 4.5 hectares, right? So from a GIS software, it will simply point out which particular what we call properties have an area more than 4.5 hectares, okay? So there are 4 properties here. And then further, tenure is not leasehold, which is actually a freehold, all right? So it will further scale down, all right, to the properties that have a freehold land tenure, all right? So it eliminates number 4 because number 4 is not a freehold. Sorry, it's not a lease. It's a freehold, right? Right? It is not yes, it's a freehold, but number 4 is a leasehold. Okay. And then further, we could also ask the software to navigate or to tell us which particular property located in PJ. All right. So from 3 items, it comes down to 2 items. All right. Also, sometimes we could further ask. Okay, we could further query until we get to a very small numbers of options. Right. So let's say here land use equals to building. Okay, these 2 properties they are building, but we also could ask for the price basically less than 60 million. Okay, per let's say per hectare. All right. So there is only 1 property that is basically suit to the queries or to the required, what we call, to the required preference, okay, of the user, right? Maybe a developer would want to find, a certain location, or maybe a home buyers, okay, would like to get to know, the traits of the properties by looking at different sets of attributes and then scale down, okay, the options to have, strict numbers only that sort of qualifies the desires, right, of the consumer or of the buyer, right? Sometimes we have a lot of data around us, but we want to scale it down, right? So the best way is basically a GIS. It links us with the attributes data, but it also links us with the actual data, actual spatial data, which is actually the map, right? And how they are linked? Basically a common, what we call identifier ID, all right? So basically this is actually a link. Data is linked by a common identifier. So the data in the map, in the spatial map, is actually linked to the database by common ID. So basically in the spatial data, in the digital data, okay, of a GIS, has each spatial map or each spatial data has a unique ID, that is parcel number, ID number 12, right? So ID number 12, ID number 12, 1212, all right? This is actually a unique identifier of this sort of place, and then it also linked to the details about this property, for example. Similar to this case, all right? Polygon P7, all right? What is on polygon P7? It is actually parcel number 390, and we have the owner, and we also have the value, right, of the parcel, right? So that's how we simply utilize a database of a map or spatial map and the attribute. And then we need to have a common, not a common, yes, a common identifier, but it's going to be a unique, what we call identifier, okay, that link between one map to the map and the attributes, or the non-spatial, what we call database. These are some of the benefits of us if we were to utilize what we call GIS on real estate. And then basically all spatial data can be represented on the map. And of course, maps are the main source of data for GIS, and maps are displayed in digital form. So we say map is the visual communication tool, right? And we can get lots of information about geographic features through a map, right? And then maps can record and store large amounts of information. There's an idiom, we call it a picture tells 1,000 words, right? Okay, that's what it tells about map, right? So from maps, we can know better about location, buildings, road, landform, and any aspects of data that are related to real estate. And then maps can be used to analyze spatial distributions and show patterns of that distributions. Just a couple of things about maps. We have different types of maps, topographic maps that show us what we call the elevation, all right, the height of a position on the earth. So 40 is basically the pinnacle or the peak of this, basically. We could say a hill, okay, let's say 40 meters, and then we have 30 meters, 20 meters, 10 meters going down, for example, right? It could also show in the outline of flattened natural man-made, and then we can have this, we call it a contour lines, okay, and then if you want to show it as a cut through, right, we can also view this way, elevation line. This contour line is actually elevation line. So this contour relates to this elevation, right? So basically, we could get to know that, let's say, Apple Hill has 40 meters height, all right, to the most top, let's say, around that, right? And Baker's Hill has what we call 50 meters, and then it goes down to 30 meters, 20 meters, 10 meters, and the aspect is actually in tandem with the contour lines on the other maps. So basically, from this map, we can tell that the shape of the hill, all right, the height of the hill, and anything associated with the properties. Okay, topography map shows the actual data for certain parts of the Earth. I think that there was an exercise during school time, right, where we utilize or we analyze this contour map, okay, or in geography subject. I don't know, during my time, I learned about that. I'm not sure about you, because when I studied during the 1990s, when I studied geography, but I'm sure you also have learned the same thing, topography. And then we can put that knowledge onto practice now, okay, on GIS. We also have a common map in GIS is actually a thematic map, all right? Thematic map is actually because a thematic equals to theme, right? Theme map, all right? So we can actually name each individual map as a theme or thematic map. Okay, let's say, for example, in this case, the theme is actually land use, right? So land use is actually one theme in a GIS map, right? We could also have building, or size, or any other sort of theme that we want to visualize on a map, right? So basically, users may deal with this thematic maps in GIS. And then these are some of the information that exist on the typical maps. Right? We have a legend and we have the key, right, to the map, right? There are a lot of geographic information on a map, all right, natural features, man-made features, all right, like houses, properties, they are all man-made, right? And then we have what we call location, the attributes, and the relationship, okay, on the spatial map. Again, for GIS, these are some of the what we call benefits, okay, of us, or the requirement or the needed capabilities or functionalities of a GIS in today's what we call application. And of course, the real world has a lot of spatial data, and as a user, right, we would want to best manipulate it to suit the purpose, right, of us. For example, you maybe in the future as a valuer, right, probably you want to utilize GIS to suit your function or your role, maybe in finding the best site, all right, to develop. For example, if you work with developers, okay, you want to find out which particular location that are probably a green field, all right, a fresh site, all right. You want to locate that, okay? So you can utilize this GIS map as well. And then, other than that, basically the Earth surface is a limited resource. Okay, everybody wants to have what we call a certain pie, okay, on the limited resources. So we want to make a better, efficient management, okay, of the use of the space, okay, on Earth. Okay, that's why we need to utilize GIS in this way. And then we could also get fast and quality information in decision making. Other than that, because of complexity of management, there are diverse data sources and types. Because of the process, because of the methods, becoming more complicated, right? And then sometimes we want to make what we call best decision in what we call shorter times. So we could utilize GIS to perform certain tasks. And then there are also, moving forward, all right, there are intense competition, okay, on the use of IT or the use of technology, right, in making decisions. Okay, remember projection, okay, beyond 2020, there will be a lot of use AI, artificial intelligence, big data, and then analytic capabilities, right, of data, objects or pieces that are much needed by the world, basically, right? So basically, there are intense competition out there, right? If you were to develop, the ability, and then there are a lot of chat applications. All right, either scholarly or simple Google right? You can find a lot of applications. And one good application is actually real estate. You can Google esri.com, ESRI.com, right? That company has information about that. Type in here, you can simply Google, we call it esri.com or MapInfo, right? MapInfo Professional, they call it, but usually Google MapInfo is actually another software, or it's another what we call company that provides a GIS solution. So these are the two most, we say, referred to companies, at least on the user level, right? S3.com or MapInfo, you can utilize that, or you can find more information about it, right? And then we also have GIS application, all right? Specific application on the area of FM, for example, maybe FM in general aspect is FM, facility management, but what GIS can best utilize is actually locating underground pipes and cables, planning facility maintenance, all right? For example, land information system, okay, it can be used on cadastral administration, taxation, loading of land use, and so on and so forth, right? So there are a lot of also application of GIS in what we call urban planning, right? They are mostly relevant to the use of GIS because they deal with a lot of space, land, right? Space of land, arrangement of space, which an urban survey, urban planners do. Okay, they arrange space spatially, right, around the globe, around the place. Advantages of GIS, digital map is better organized and kept. These are some of the benefits of us utilizing what we call technology in the form of digital, right? Maps data can be integrated or shared internally or externally. That is actually a huge what we call benefits of a GIS. We could share the data with others, and then sometimes data from s3.com could also be read, okay, from mapinfo.com, for example. And some software like MapInfo can read data from AutoCAD drawings, right? AutoCAD, okay. It depends, okay, on the capabilities of each software or each what we call proprietary software, okay, developed by the company. Here's some benefit. Basically, we can read this up, no problem, right? From the traditional descriptive mapping, just would allow for advanced descriptive or expanded mapping. And then because of map in a digital format, it can be easily be updated or changed or merged, right? In order to create new maps, let's say you want to create a new theme, okay, we could simply combine any layers of map, all right, and then provide with new themes. We will show you this example, okay, later on. And then GIS provide a huge range of tools, allow for accuracy of output and thoroughness of decision making, and allow for easy immediate integration with other technologies, for example, GPS, because GPS normally acquire position, data about position, right? And then as well as a survey. Okay, a survey data could also be be channeled through GIS, okay, capabilities. And probably lastly, GIS allows for the display or visualization of specially related data in a way which is easily comprehensible to most people, right? Of course, if we look data or if we visualize something as a picture, right? Sorry, we can get better informed about it, okay, rather than reading a description about things, okay? Let's say you want to get, to know, let's say give a real example, right? You want to get to know your say boyfriend or girlfriend, right? You would want to see his or her, okay, rather than reading the description, okay, from the narrative way, okay. So we want to better visualize, so we get better informed. So we could formulate our decision making, right? Okay, that are all about the first topic, introduction to GIS in real estate. Basically, this is a typical what we call activities that we usually do in GIS class. Actual class. But for now, because since we only could utilize GIS in a more lighter way, we would see GIS in contextual form, right? And we try to implement a bit of sort of hands-on through, like I said earlier on, Google My Net, all right? So basically, in this semester, we would not really utilize GIS as hard as it was usually be, okay, in the previous years. So we only see it, through a lighter version, okay, lighter aspect, as long as we could understand the basic principles underlying, the use of spatial data, all right? Okay, guys, any questions on this? Any questions? Is that the ice cream van? No. Yes. Can you speak up?
So can you go back to slide number 19?
Sorry, slide number berapa? Number berapa? Slide. Which slide, yeah? Which slide, please?
Shira, kenapa tak tangkap Shira?
I can't hear. Slide number berapa?
Tak tahu, Shira yang minta.
Okay. We lost her.
Tapi sekarang Shira sudah mute.
Okay.
Tadi saya cari
Yes, please.
slide number 19.
19. All right. Okay, what we can see here in number 19, right? Yes. What about it?
Question number 2.
Uh-huh.
West, north, 4 west. How do I know 4 west?
Just by looking at this position, because east is this side, and then of course west is on the other side, right? I mean, through the navigation of the geography, we have north, south, and then east and west. Although we don't name this side west, but we know it is actually west, right? Correct. Boleh tak? Boleh faham, itu simple je. So 4 west.
Anything
Because
that's
4
on the left of the north is west. Macam tu.
Yes. Relatively. Because S is more or much closer to the west side of this sort of map. Like Q is more on the east side, right? And R is more on the east side. The southern part. So basically, we look at features where it is actually close by.
Like R is more to the east.
Yeah, R could be, yes, more to the east, because you look at the boundaries, it's more towards east. Yeah. Right?
Okay.
So the center of R or the bulk of R border here is more towards east. But if you want to know the actual R, okay, we need to verify it by looking at the latitude and longitude. Then we can get to know the exact sort of position.
Okay, that's
all right.
Thank you.
Okay, no problem. Yes.
In terms of the mapping, like just now show the coordinates of the property or the location. How do we set the origin point, or we can set whatever we want?
Okay. Yes. Basically, in the software, okay, we have to work on the available map that we have from other sources, because normally when we got this map in digital form from other sources, we would already have the what we call the one that you said. We already have the position, the starting point, because so we just simply acquire that, and then put in the data, put in the software, and then we already have the actual position, okay, of the map as it is.
Okay.
Yes.
Okay.
Yes.
Thank
Because yes, thank you. Normally we don't do it from scratch. We have what we call the data already. What we do is mostly we simply what we call that manipulate, okay, the data to suit for our purpose. All right. Okay. Any more questions on this? Okay, I'm going to show you a bit more, a little bit more about your task. Here, this spectrum, right? Okay, what we're going to do is actually, just try to do the quiz, tutorial 1, just a simple quiz. And then the most important thing is actually for you to utilize, or for you to get to know Google My Map, right? Because we would utilize Google My Map, okay, throughout the process of learning about GIS, right? So basically, try to do tutorial 2 activity as well, right? And maybe we would talk about it on was it Thursday, right? Depending, or you can also utilize that Thursday to do this map, right? So we don't have any online session, right? So basically, we would want to, sort of give a lighter way, or more flexible way for you to learn GIS. Yeah. So basically, I have put 2 sort of videos on how you are actually going to get started with My Maps. Of course, you need to have a Google account, and then you need to sign in, and then you follow through this map. So this video to get to know how you would want to create a Google map, right? And then we will try to see it on Thursday, okay? How we can best, use or utilize Google My Map. All right, class. So basically, that's all for today's session. Introduction to GIS, and later on we would see a lot of other functionalities or capabilities of GIS. Okay, when we go further. All right. So thank you very much for your attendance, for listening, and have a good day. Thank you very much, guys.
Thank you, sir.
All right, all the best to everyone.